In 2018, I made an animation about the International Space Station. I showed all the pieces coming together, but I didn't show how it was done.
These modules didn't just float together on their own. It was a lot of work.
It involved mission controllers back on Earth, astronauts on board the station, and some fancy robotics.
In this video, we're going to dive deep into the details to see how it worked.
The International Space Station took over a decade to complete. Most of the pieces that you see here were launched by the space shuttle.
In fact, this was one of the main purposes of the space shuttle. It was to build the space station.
We can't go over every single mission, so...
That would take too long for this video.
What I'd like to do is talk about the initial stages of the station's construction, back when the ISS was really small.
We've got to remember, the station isn't just aimlessly floating in space. It's going incredibly fast, about 20 times the speed of sound here on Earth.
It orbits the Earth once every 90 minutes.
So this is forward and aft, port and starboard, and then there's zenith pointing away from the Earth and nadir pointing towards the Earth.
This is what the completed station looks like. The only part that the astronauts can live in are the pressurized modules. It has air to breathe, comfortable living conditions, and protects the astronauts from the vacuum of space.
Each module has one or more berthing ports that can be connected to other parts of the station. Sometimes these are referred to as docking ports.
There are two main sections to the station. The Russian orbital segment, these are modules from Russia, and the United States orbital segment.
On the US side, the modules are connected by the Common Berthing Mechanism, or CBM for short.
There are two different sides to this, the active side and the passive side.
Once these are brought together, latches pull them in close, and then there are 16 bolts to firmly make them together. The space in between is called the vestibule. This will be pressurized with air. This process takes a few hours.
The Common Berthing Mechanism is used for modules that are permanently attached together, like the Harmony and Destiny modules.
They can also be used for visiting spacecraft, such as the SpaceX Cargo Dragon.
The Russian side of the station uses a different docking mechanism that is not compatible with CBM.
We need some way to connect the different mechanisms. And bound.
This is kind of like taking a power plug from the United States and bringing it over to Europe. It's not compatible with the wall plug. What do we need? An adapter. It's the same concept on the space station, but on a larger scale. Two different mechanisms, so we need an adapter in between.
The larger side uses CBM, which can be attached to the US side of the station.
The smaller side uses APAS. This is compatible with the Russian side of the station and with the space shuttle.
On the station today, there are 3 of these adapters.
The smaller side, which is the side that uses APAS, was used for the space shuttle. This is how it would dock to the space station.
If you'd like to see this in action, you can watch my SpaceX Crew Dragon video. I'll leave a link in the description below.
The crew spends most of their time up here in the crew compartment. Up front here is the orbital docking system. This is the place that could dock to the International Space Station. The astronauts can also do spacewalks from out of this hatch.
On the side here is the Canadarm. It's a robotic arm that is capable of moving things around in space.
The Space Shuttle launches took place from Kennedy Space Center in Florida.
Once in space, the payload bay doors were opened. They remained open for the entire time they were in space.
Then it took a few days for the space shuttle to catch up with the ISS.
The space shuttle is retired now, but it played a crucial role in building the space station.
Let's take a look at a few of these space shuttle missions. This first mission we'll go over in a bit more detail.
The first mission we'll talk about is STS-88 in December of 1998.
And the STS stands for Space Transportation System. All shuttle missions started with these three letters.
This was the first shuttle mission to the International Space Station. At this time, the station had only one piece.
On the completed station, this is where Zarya is. And this first shuttle mission brought up the Unity module. This is kind of like the center hub of the station.
On day 3 of the mission, the Canadarm was put to work. It was time to lift Unity out of the payload bay.
The shuttle's thrusters were fired to bring the modules together.
On the 4th day of the mission, the space shuttle slowly approached Zarya. The Canadarm
Again, the shuttle's thrusters were fired to bring the modules together.
It took a few more days of preparation before they could go inside the station. There were 2 EVAs where they get into their spacesuit and go outside the station.
They connected cables and installed antennas on the outside of the station. The Canadarm was used to help move the astronauts around.
On the 8th day of the mission, they opened the hatch and entered the station for the first time. They only stayed inside for about a day to check things out.
On the 10th day of the mission, there was one more EVA to finish the installation.
On the 11th day of the mission, the shuttle undocked from the ISS.
At this point, there was no permanent crew yet. The station was too small. Unity and Zarya orbited all by themselves.
Then we'll fast forward just a few years in time.
The station had a few more modules, and there were 3 crew members living on board the station.
The next mission we'll talk about is STS-98 in February of 2001.
So here's our completed station. Here's what it looked like right before STS-98. This mission brought up the Destiny module.
STS-98 lasted for 13 days. They were attached to the station for only 6 of those days. They docked to PMA.
The arm was used to attach it to the forward berthing port on Unity. The next day, they opened the hatches and went inside Destiny for the first time.
PMA-2 was then relocated to the forward side of Destiny. The mission had 3 separate EVAs to connect and install items on the outside of the station. The purpose of this next mission was to give the station its own robotic arm, called the Canadarm2.
The first Canadarm was on the space shuttle. Very useful. but it was permanently attached to the shuttle. This means it goes home at the end of a shuttle mission.
The Canadarm2 can lift heavier loads and would now stay on board the station, so it can be used in between shuttle missions.
The mission that brought up the Canadarm2 was called STS-10 Dread.
It was a 12-day mission. The shuttle docked to the front of the station at PMH-2.
This carried Raffaello, a multi-purpose logistics module, which would be temporarily attached to the station. The second piece of cargo was the Canadarm2.
The shuttle's Canadarm grabbed onto the pallet and lifted it out of the payload bay, and then attached the pallet to the top of the Destiny module.
Holler. This was the first robotic handshake in space, sometimes referred to as the Canadian handshake,
because the empty pallet was then put back into the payload bay. A few days later, the shuttle undocked from the station.
The last mission that I want to show in this video is STS-104.
So here's the completed station, and here's what it looked like right before STS-104. This mission brought up the Quest airlock.
Then to Homeworld. This was the first time they used the Canadarm2 to help construct the station. The Quest airlock. Once Quest was installed, it was time for the high-pressure gas tanks. Once again, the Canadarm2 was used to move the tanks around.
Now the airlock hatch is opened, and then the thermal cover on the outside. The opening points straight down, so the first thing they see is the Earth right beneath them.
This video summarized 4 separate shuttle missions, just to give you a better idea of what it took to construct the International Space Station.